Hello everyone, welcome to our new session of fluid mechanics subject. Today we are going to start our new session and the new topic, that is the losses of energy or the heads in pipes. So there are lots of losses in terms of energy or in terms of pressure head which occurs in a pipe whenever you are going to flow any fluid from the any pipe material. So let's see, there are different types of energy losses or the loss of head is in the pipes, and how we can classify that's a loss of energy in a pipe. And this type of questions they are asking in examinations, like classify the losses of energy in a pipes, or classify the loss of heads in a pipe in terms of friction, or also they can ask like state the major losses which occurs in a pipeline or the minor losses in a pipe. So let's say how we can classify these different types of losses which occurs in a pipe whenever the fluid is flowing through the pipe. So let's start our today's session. So whenever fluid is flowing through the pipe, the fluid which experience some resistance, and that resistance which occurs due to the friction, and because of that friction the energy of a fluid is lost between that fluid particles and the surface of pipe. So mainly there are two types of classification of this energy losses. In that first one which is a major energy losses, and second one that is a minor energy losses. So let's see what is major energy losses. So in today's session we'll cover about major energy losses, and that is again classified in two terms. First one that is Darcy-Weber equation, and second one that is Chase's formula. So major energy losses is mainly occurred due to the friction, and it is calculated by the following these two formulas. Okay, so whenever there are losses in a pipe that because of a friction, so this kind of losses is called major losses. But if we say there are another types of losses which also occurs in a pipe, and that is the sudden expansion of pipe or sudden contraction of pipe. There is a lots of bend in a pipe and extra fittings in a pipe, or any obstruction that is put into the pipe. So these all are the different possibilities. Because of that the fluid is a resistance in the pipe. So this type of losses is called minor energy losses, and the major energy losses is occurred due to the friction in a pipe. So let's start our today's session, that is basically on the major energy losses which occurs in a pipe. Okay. So here it is, the losses of energy or a head due to the friction, that is our major losses. In that first one which is Darcy-Weber formula. Darcy-Weber formula, and that Darcy-Weber formula which is already derived in our previous session, and that was the head loss due to friction HF is equals to 4 FLV square divided by 2 GD, where F is denoted by friction factor or the friction coefficient. Okay, so in this equation which is already derived in our previous session, so please watch out that previous session which is most IMP topic, that is Darcy-Weisbach formula. And this equation is gives us a friction head loss in a pipe, that is 4 FLV square by 2 GD, where HF is denoted by loss of head, or loss of head due to friction which is denoted by HF. F is known as the coefficient of friction, which is the function of Reynolds number. So whenever you are going to decide, or whenever you are going to find the coefficient of friction, first of all you need to find out the Reynolds number. What is the Reynolds number? And depends on the Reynolds number, that will be less than 2000 or greater than 4000. After the finding out that Reynolds number, we can have a proper idea about how to find the coefficient of friction F. Okay, so when there is a viscous flow, it means when your Reynolds number is less than 2000, so this type of flow is known as viscous flow. And whenever there is a viscous flow, you can find this coefficient of friction by this formula, that is 16 divided by Reynolds number. Okay. Again, I am repeating this line. Whenever you need to find out the friction coefficient F, at that time you can use this equation, that is 16 divided by Reynolds number, when there is a Reynolds number is less than 2000. It means whenever there is a laminar flow or a viscous flow. But when you are having a turbulent flow, which means that the Reynolds number is varying from the 4000 to 10 to the power 6, at that time you need to find out friction coefficient by this formula, that is 0.079 divided by Re raised to 1 by 4. That is the formula for the turbulent flow. It means whenever the Reynolds number is greater than 4000, at that time you can find the friction coefficient by this formula. Okay, I hope you are getting this. So you need to remember these two equations. First of all, that is for the viscous flow and for the laminar flow, and the second equation is for the turbulent flow when the Reynolds number is greater than 4000. Okay, in this equation, L is shows the length of pipe, where the V is the mean velocity of flow, that is in meter per second, and D, that is the diameter of pipe. So you need to remember this equation also, that is the FLV square by 2GD Darcy-Webic equation, that is used to find out the loss of head due to friction. Let's move forward for this our chassis formula, which is used to also find out the loss of head due to friction in a pipe. Okay, so how we can find that? So if you remember this equation, that is derived in our previous session, basically to finding out the Darcy-Webic equation. At that time we had this equation, which is the F dash divided by rho g into P by A perimeter divided by area into L into V square, that is our HF. So in this equation, HF is again loss of head due to friction, A, that is the area of cross section of pipe, V, that is mean velocity of flow, P, which is weighted perimeter of pipe, and the L is the length of pipe. Okay, so in this equation, A divided by P is called as the hydraulic mean depth. A divided by P is called as hydraulic mean depth or the hydraulic radius, which is denoted by small m. Okay, A divided by P. So simply we can say that m that equals to A divided by P, where A, that is nothing but the area of the cross section of pipe, that is pi by 4 d square, and P, that is your weighted perimeter. So in this case you can cancel out this pi d with this pi d, and the remaining term, that is d divided by 4. So it is over here m is equal to d divided by 4. Let's put this value A divided by P, that equals to m. So reciprocal of AP, that is P divided by A, and that equals to reciprocal of m. Let's put this equation, let's put this value in place of P divided by A. So we are putting this value 1 divided by m in our previous equation. In this previous equation, in place of this PA, we are putting this 1 divided by m. So over here it is 1 divided by m. Or we can write that V square, that equals to HF into rho g, HF into rho g divided by F dash divided by this F dash into m into 1 divided by L. So also we can write this equation in this form, and in this form again after the simplification, rho divided by F dash m, and the third component, that is HF divided by L. So in this equation, this whole equals to V square. So this square is going to the right side, and it will be your square root or the under root of rho g divided by F dash into m into HF by L. And again after the simplification also we can write this in this format. So in this format, this root of rho g divided by F dash, it is called as a C, capital C, and this capital C is known as the chassis constant. This capital C is known as chassis constant. So C that equals to under root of rho G divided by F dash. Also in this equation, this HF divided by L, root HF divided by L, HF divided by L, that is equals to I, where I is loss of head per unit length of pipe. So HF is loss of head divided by L, it means per unit length of pipe. So HF is also replaced by I. Let's put this value in this equation. So after putting this value, we can write that V, that capital V equals to C under root of M into I. So this equation is known as Chase's formula. This equation is known as Chase's formula, and it is used to finding out the loss of head due to the friction in the pipe. Okay. So this was all about our today's session. As a task of this session, you need to write down all these things by yourself and submit it to our Google Classroom. Thank you.